Okay, so this says Mr. Keller filled out a bracket for the NCAA national tournament based on his knowledge of college basketball. He has a 64% probability of guessing any one game correctly. So it says, what's the probability that Mr. Keller will pick all 32 of the first round games correctly? You could either figure out the number of ways of picking all 32 teams, and then there's just one way of doing it, or all three of these can be calculated using the binomial distribution. Okay. So this is a binomial. X, the number of games he guesses correctly is going to follow the binomial with 32 trials and a success rate of 64 on any given event. 32 games, 64% chance of guessing the game correctly. Okay, so this one, if you're looking for all 32 teams, that would be, we're looking for one specific value, all 32. So we get binomial PDF, 32 trials, success rate 64%. X value, he wants all 32 correct. So that's where you got this answer here, 6.277. Now, what if I said the probability of exactly 12? That's going to be the same thing, except instead of 32, we want exactly 12. So this would be 0.001425. And then the last one is intentionally misleading. It says, what is the probability that Mr. Keller would pick exactly 26 games incorrectly? So if there's 32 games altogether, 26 incorrect would mean he's selecting 6 games correctly. So this is binomial PDF again, and he wants 6 correct answers. So we get 1.812 times e to the negative 7. Okay, if they said something like 12 or fewer games, remember that's going to be a binomial CDF. But for any specific one value, exactly, you're using binomial PDF.